Hello everybody and welcome back to the course. So in previous lectures we've seen that our thinking can be predictably unreliable in certain contexts. We've also seen why this is the case. We've traced the evolutionary origin of that irrationality and we've seen what this can lead to. We've looked at these domains of irrationality. And today we're going to talk about how we can guard our thinking against reasoning errors, how we can improve our thinking, how we can become critical thinkers. And in order to do so, well, we must first of all understand the three sources of reasoning errors. So I hope by now these will be known. This is what we've covered in the lecture on why we are irrational, on the evolutionary origin of our reasoning errors. And so we've seen that there are three major sources of reasoning errors. First of all, we have our intuitions. We have system one, which can lead us to reasoning errors because, first of all, it is approximative. Remember that natural selection endowed us with a fast and frugal economical thinking system, and therefore it is not always right on the mark, but also because of error management. Remember the fire alarm principle. Natural selection is only interested in reducing the costs of mistakes. So sometimes in certain contexts it was willing to make more mistakes to avoid costly mistakes, like for instance not missing any causal patterns. So we have this hyperactive pattern detection. And then finally, our intuitions can lead to reasoning errors because we apply them to problems and contexts for which they were not designed. There's a mismatch between the problems we apply them to today sometimes and the problems for which they were developed. Those were our evolutionary relevant problems. And then a second important source of irrationality are emotions. As I said, we're not cool-headed robots, but we're hot-headed primates, and that has an important impact on our thinking. And then finally, also system two, or conscious slow reasoning processes, well, they too can lead us astray because, as mentioned many times before, the most important of all biases follows from our tendency to see and look up and remember confirming evidence and confirming information much more than disconfirming information. And this important confirmation bias, well, leads to the overconfidence bias, the fact that we often overestimate the chances that we are right, that we predict correctly, and so forth. And so today we're going to see how we can guard ourselves against these three sources of reasoning errors. So first of all, how can we guard ourselves against intuitive reasoning errors? Well, importantly, we must realize that system one can never be switched off. There's no switch for system one. So even in contexts where people are trained not to use system one, not to use their intuitive thinking, but to use slow, conscious, reflective processes, like in the modern sciences, it seems that they are still vulnerable to having their thinking distorted by certain kinds of intuitions. So they're not immune to intuitive reasoning errors. None of us are. And a good example of that is in the so-called paleoanthropology, the science of the evolutionary history of humans. And so there's this very important intuition that humans have, that actually all animate organisms on this planet have, a sort of instinct that makes a very strong distinction between conspecifics, members of your own species, and members of other species. Now this is obviously very important, and that's why all animate organisms have such an instinct, such a strong intuition, for the reasons of mating. Obviously it only works if you mate with conspecifics, but also competition and collaboration with conspecifics, with members of your own species. So a very strong intuition there, distinguishing between your own species and other species. Typically in the human language, in almost all human languages, there's one word that describes all other animate species, animal, and we use human for our own species. Although, again, very obviously, we share much more with other primates or even other mammals than other mammals would share with, let's say, fish or insects. But anyway, so we have this very strong intuition that makes a strong distinction between members of your own species, of our own species, and members of other species. And that intuition was strongly violated by the theory of evolution by natural selection, in which we first hypothesized for the first time, discovered that we share common ancestors with other species, and later that we share a lot of genetic endowment with other species as well. But even in the science where this intuition was strongly violated, apparently it was still present on the background, namely in paleoanthropology, where they described the recent evolutionary history of humans, the evolutionary history between our common ancestor with other primates and the modern, biologically modern human beings that we are now today. So for a long time, and actually many people still believe this, this process or this evolutionary history was thought to be a unilineal process or history, meaning that between our common ancestor with other apes and biologically modern human beings, there were thought to be, fixed intermediary kind of species, like you see on this picture. So, first of all, Australopithecus, then Homo erectus, Homo habilis, and then all the way up to Homo sapiens. But this was very different from the evolutionary branching pattern we see in other species. So typically, you'll have a species at one time, and that will branch out into different species, which again will branch out, and some branches will die out, others will again branch out, and so forth. And so we thought this wasn't the case for humans, and the reason paleoanthropologists gave for that was that because humans possessed, albeit primitive, forms of culture, they were able to thrive and survive in very different environments without having to develop, physical and other specific adaptations to different environments when they migrated. And that's why we've evolved to biologically modern human beings all together, all of humanity together in a fixed set of steps. Now, the more fossils we're discovering about ancient hominids, the more we realize that this idea is completely misgiven, that much like any other species, there were at certain points of times in our history many different human species, cousin species like Neanderthals, Denisovans, and so forth. They've even discovered the remains of what looks like a human species, a dwarf-like human species on an island in Indonesia, in Flores, and that humanite, if you will, lived some 30,000 years ago. So when Homo sapiens was already there for 170,000 years, and that human species had a skull no bigger and a brain size no bigger than modern chimpanzees, and as I said, was dwarf-like, was very different. And so now more and more we come to realize that there were many different branches of human species. The reason that today there's only one human species, Homo sapiens, has everything to do with the fact that we outcompeted all of the other species and drove them to extinction. But so for a very long time, scientists were kind of misled by this intuition that humans are radically different than other species, and so thought their recent evolutionary history was different as well, which we now realize more and more is not the case. So system one still working and distorting thinking of scientists on the background. And so critical thinking and scientific thinking in this context as well consists in not just trusting and going with obviously the output of our intuitions, but using system 2, using our reflective conscious reasoning processes to check the output of system 1 and to override that output when necessary. And that kind of, you could say, guideline of critical and scientific thinking seems to be in strong contradiction with this kind of vague advice you hear in modern popular culture, that is that you should trust your intuition, that there's some kind of wisdom in our intuition and that we should follow that intuition. But this, and from what we've learned, and especially what we've seen in the lecture on Predictably Irrational, it should be clear that this is not always sound advice. Or intuition, as we have seen and we've discovered why, can very predictably in certain contexts lead us astray. But does that mean we can never trust our intuition? No, not at all as well. In fact, it depends. So in order to answer the important question, when can we trust our intuition? Well, we first must get a grip on what exactly is intuition. And intuition, so our automatic reasoning processes that come effortlessly and just pop an answer into our head without us even wanting to consult certain reasoning processes, well, they actually arise from two different sources. First of all, you have the genetically anchored reasoning processes. Those are the kind of evolved intuitions, which, as we have seen in the lecture on why we are irrational, well, they've evolved to give us quick and relevant representations of our environment in order to make us survive and reproduce. But secondly, and we'll come to that in a second, we also have acquired intuitions. And so first, let us talk about those genetically anchored reasoning processes. Now, we've seen that in certain contexts, these reasoning processes aren't to be trusted. And we've explained why that is the case. They're approximative. There's the issue with error management. And then finally, there can be a mismatch between the problems we apply them to and the problems for which they evolved. And that is why we can be predictably irrational because of these intuitions when we apply them to certain kind of problems or certain kind of contexts. But as I've also emphasized in that lecture on why we are irrational, those intuitions that have been shaped by natural selection, well, truth wasn't the goal of natural selection when shaping or system one or intuitive reasoning processes. It wasn't the goal. The goal was, as we know, survival and then obviously reproduction. But it was, at least when it comes to navigating our natural environment, the best strategy in general to get our ancestors to survive and reproduce. So accurately representing your environment is generally better than representing your environment in a mistaken way. And so, in general, these intuitions are pretty truth tracking, as they call it. They lead often to true representations of the world. And against the research by people like Kahneman, who came up with System 1 and System 2 and who discovered that these intuitions can be wildly unreliable, well, there's been a response from other psychologists, most prominently Gigerenzer, a German psychologist, who argues that these intuitions and the heuristics underlying that intuitive thinking, those heuristics, remember, are the kind of thinking rules of thumb, if you will, that we apply unconsciously to certain problems, like the availability heuristics. What is most likely in your environment, what is most easy to recall will be most likely to occur in your environment. And that's why in certain cases it can lead to biased reasoning, thinking that shark attacks are more common than attacks from dislodged aircraft parts. But as Gigerenzer points out, in general, this intuition and other intuitions, other heuristics, they work very well and they lead to true representations. In general, what is most easy to recall is also most likely to occur in your environment. So Gigerenzer says, well, intuitions, genetically anchored, evolved reasoning processes, evolved intuitions, well, they do not lead to irrationality, as Kahneman and some others have argued, but they lead to ecological rationality. They lead to rational inferences, at least when it concerns problems that are ecologically relevant, problems that aren't far removed from the problems we've encountered throughout our evolutionary history. And the reason Kahneman found out all these biases when we use our intuitive thinking, according to Gigerenzer, is that he had these intuitions applied to artificial contexts, not ecologically relevant contexts. So what he says is Kahneman tested people in labs on their reasoning errors, and he gave them all sorts of problems like the Linda problem, remember, and a bunch of other problems that were specifically designed for these intuitions to go wrong. But actually, in everyday life, those intuitions, system one, is actually pretty right on the mark, is doing very accurate kind of predictions. For instance, when it comes to who is trustworthy in our society, who's cheating the group, and so forth, we seem to be very attuned to have an intuitive, good understanding of that because of the important evolutionary consequences solving these problems had. Or, as I said, what is most likely to occur in your environment based on, for instance, the availability heuristic. But so it is incredibly important when we apply these genetically anchored intuitions, these evolved intuitions, that we check the proper context in which they are used. If that context is very close to the evolutionary context in which they evolved, kind of everyday problems that we would have had to solve throughout our evolutionary history, well then, these intuitions are generally reliable. If, on the other hand, they are applied to contexts and problems that are very far removed from the typical problems and we had to solve throughout our evolutionary history, think about financial analysis, science, modern science, in fact, in general, but especially counterintuitive modern sciences like quantum physics. Well, in these, or think about statistics, as we said in general, we're poorly attuned to estimating probability because we didn't really have to deal with many of these probabilistic issues in our evolutionary history. Well, in all of these contexts, well, our intuitions or evolved intuitions are not reliable and we shouldn't just go with them. But in everyday contexts for problems that are ecologically valid, meaning problems we've encountered throughout our evolutionary history, these intuitions, as Gigerenzer pointed out, are for the most part trustworthy. And then of course we also have to be aware of cognitive pitfalls, mostly due to error management. We know that we make causal connections too easily, that we see many patterns that aren't there, especially causal kind of patterns and connections. So whenever we infer all these patterns and connections, well, we should be wary. There should an alarm bell should go off because we know we over detect these. And then there's this second kind of intuition, and those are acquired intuitions or acquired automatic reasoning processes. Now, the most simple example here is driving a car. Now, when you first learn to drive a car, when you first step into a car you've never driven before, well, everything has to go through system 2, to conscious reasoning processes. So your teacher explains you, well, first thing you have to do is you have to put the key obviously in ignition, start the engine, put it in the first kind of gear with the pedal and so forth, and then you have to look in your mirror, and then you have to loosen the pedal, give some gas, well, you know, the whole shebang. Anyways, in the beginning, this is very hard because we're doing everything consciously and we have the sequence that we have to remember, and so we forget one part and it doesn't really work. But as we gain more experience, as we go through that learning process, well, gradually everything, all these actions, all these necessary behaviors to successfully drive a car, well, it all moves to system 1. It all becomes intuitive, automatic, and we can drive a car without even thinking about driving a car. We can drive a car while having a conversation with another person, thinking about other stuff, having a phone call, and so forth. So it becomes an automatic reasoning process. And it becomes so because we do it and we do it again and again because of repetition and because of that learning process. And there's a whole bunch of examples of these automatic reasoning processes. In fact, many of the learning tools you acquire are to make certain kind of cognitive tasks, make them easy, automatic. And a good example of that is chick sexing. That means determining the sex of very young chicks. So they can be small roosters or they can be chickens. It's very hard to see when they're very young, and there's important economic interest to make that distinction and to separate the chicks from the roosters, because the roosters, they go straight to the meat industry, and the chickens, they will be used for laying eggs and for the egg industry. And so now there's many machines that are able to do that, but before people had to make that difference, and it's incredibly hard to see the difference. And there's no one characteristic that shows you, well, this will be a chicken and this will be a rooster. And there are training programs, and this was especially done in China, I believe, training programs that went up to 1 or 2 years even of hardcore intensive training in order to be able to see the difference between chickens and roosters and see that quickly and accurately. Now, interestingly, at first nobody has a clue. Then the more and more you get acquainted with, looking at the sexes of chicks, well, the better you start performing. And at the end, when these people have gone through the whole training process, well, they just look at the chick and they know in the blink of an eye if it's going to be a rooster or a chicken. And interestingly as well, if you ask them now, like, why did you put this one in the basket for the chickens and this one in the basket for the roosters? Well, they can't really remember why exactly they said that, what exactly the characteristics, what exact characteristics they detected to make that distinction. They look at a variety of different kind of characteristics and they do it all, intuitively, and they're extremely, extremely accurate. So a typical case of something that first goes with a very long checklist and then making some kind of weighted choice, system 2 making the difference, going to system 1, just in a blink of an eye, intuitive, very accurate distinctions are being made. Another example comes from Malcolm Gladwell's book Blink, in which he writes about the power of intuitive thinking. That's why in the blink of an eye we can make good judgment calls. And he has this story, also true story, about this ancient sculpture that is being bought by a fancy museum. And they do all kinds of tests on that, and scientific tests to determine whether or not it's an original, because it's wonderfully well preserved, and so it would be of enormous value. And so it passes all of these tests, they buy it, and they have their big opening to unveil the sculpture to the public. But before the big opening, they have just a bunch of academics and scholars and art connoisseurs who are specialized in these kind of statues. And they invite them over for the pre-opening. Now, when they have these people, so people who make it a living to write and think about these and who have seen many of this type of sculptures from that specific period, well, these people straight away, independently from each other, look at it and kind of know, no, this is not a genuine sculpture, this must be a fake. And when interviewing them, well, they said it's not so much that there was 1 or 2 characteristic that obviously made it that case. It's just, this didn't feel right at all. And so it was very much the same kind of intuitive thinking that was at work here. And it turned out they were right. It was indeed a forgery. So our intuitive thinking, when it's acquired and when it's a product of a learning process, well, is actually incredibly reliable. So the manual for the use of intuitions. When is an intuition reliable? Well, first of all, we must ask whether the intuition is innate or acquired. If it's acquired and it's, as I said, the outcome of a reliable and a good learning process, it's generally very reliable. If it's innate, on the other hand, we must ask whether we apply it in an ecologically valid domain. If we do so, well, in general, intuitions will be reliable. If we do not, if we apply them to a domain for which it did not evolve, well, an alarm bell should go off, because then they can be, and they are generally, wildly unreliable. All right, so should you trust your gut? Should you trust your intuitions? As you know, hopefully know, well, it depends. Ask where the intuition comes from and to what problem it is applied. All right, then on to the second source of biases, of reasoning errors, of tainted reasoning, and that source is emotions. And emotions, well, they can lead to irrationality by, first of all, determining which kinds of beliefs we do and don't take on board. Remember the in-group, out-group bias. We're way too uncritical, typically from beliefs that come from our close environment. We take them on without much, critical gauging if they're actually rational, if they're supported by evidence and so forth. And it seems that we're very uncritical, too uncritical, often it turns out, for information, beliefs, opinions, predictions that come from people in the out-group. So that's one first important way in which emotions bias or beliefs by determining which beliefs we take on board. And we've covered that. But then there's also perhaps an even more important way in which emotions distort our beliefs and can lead to irrational beliefs, irrational conclusions. And that is because they also play a role in determining which beliefs we refuse to discard or adapt in the face of counter-evidence. It appears that we tend to develop emotional ties with our beliefs, and once we've done so, we refuse to just let them go. And this was discovered in the 1950s by the psychologist Leon Festinger. And what we do when we developed strong ties, strong emotional ties with a certain kind of belief, and we find strong counter evidence for that belief, well, we do what we've covered in the tutorial. We do an irrational form of cognitive dissonance reduction in order to save our belief from falsification. So we're going to work on the interpretation of the new information we're getting in order to be able to keep to our belief, to save that belief from being refuted. And Leon Festinger, he discovered that, as I said, in the 50s, and he was very interested in all kinds of religious, but also, the thinking of people belonging to sects. And he was studying, or at least he was following this one sect, this one cult, if you will, this one cult known as the Clarion believers. And so these people in the 1950s in California, in the United States, well, they had this very precise prediction that on the 21st of December 1954, there would be a second flood, a second biblical flood. So God would once again, flood the whole earth because man had been sinful. And differently than the first time around, this time there wasn't going to be an ark. But what was going to happen is that the true believers and the pure people, which they were going to be saved by aliens coming from another planet, a planet named Clarion, and they were going to continue humanity on that far-off planet, and a purer form of humanity rid of all its sins. So, Festinger knows about that, and he drives up to California to go and investigate what is going on and what will happen. So he's assuming, well, there will not be a flood, and there will not be any alien abductors or saviors, and so, which is obviously pretty rational to assume. And he was wondering how the members of the sect or of the cult would react to that strong falsification of beliefs they held very, very dearly. And so the morning of the 21st of December 1954, all those cult members, they were standing atop of a hill in California, waiting for the flood and waiting to be saved by the aliens. And Festinger was observing the whole happening. As you can imagine, as the day grew to an end, there hadn't been a flood and there hadn't even been a drop of rain, and there were no aliens that came along. And so what would these members of the cult do? Well, a few of them, they left disillusioned. They said, well, we've been lied to by the cult leader. It's all bogus and bullshit. Bad on us. Okay, they left the cult and that was it. But that was a very small percentage of the cult members. Most of them went along with a wildly new story and a very interesting way of reducing the cognitive dissonance, the tension between their belief and the fact that none of their predictions had come out, so the information they got from the world. And what they came up with was that God, at the very last moment, had aborted the whole mission, had aborted the flood, because of their belief. He had regained some confidence in humanity and decided not to flood the planet and let the human experience continue some more. So a wonderfully original and typical way, but obviously very, you could say, extreme way of reducing that very strong dissonance, tension between falsifying information from the world and a belief that is being held. And in one way or another, we're all kind of guilty of doing that. Obviously in much more subtle ways, but irrational dissonance reductions, well, you find them in everyday life. Think about the person who sees himself as you could say, a green person who's concerned with the fate of the planet and climate change and so forth, but who received a car from his parents. It's a pretty polluting car, but he doesn't want to sell the car because he really doesn't have the means to buy another one. So he doesn't want to discard the car, and he's kind of rationalizing, saying, well, yes, if I sell it, well, it's just another person is going to drive it, or one car is not going to make much of a difference anyway. Or think about a smoker who wants to live a healthy life, but can't really give up smoking, and therefore rationalizes that, well, yeah, it's not great for your health, but there's, but okay, I mean, it's not that bad, and perhaps if I stop smoking, well, I'll start eating more, I'll gain weight, which also is unhealthy. Or, you know, the professional athlete who's taking doping and who rationalizes by saying he doesn't want to see himself or herself as a cheat, who's rationalizing by saying, well, everybody does it, so I'm not really cheating here. And while these everyday examples are still pretty, small scale and don't have, profound consequences, some a bit more than others, well, dissonance reduction, irrational forms of dissonance reduction can and do have very important negative consequences on the world, especially when you look at politics. Now, it appears that politicians, once they've held a certain kind of view and defended a certain kind of policy, they will be very tempted to stick to their views even when they get strong counter evidence, for instance, because there's new scientific evidence going against what they stand for. Think about climate change. The climate change denier who denied it in the 70s, and there wasn't much research back then, so who could still, more easily deny it, is pretty likely to have kept denying it even though in the face of the amassing, overwhelming scientific evidence for man-produced climate change, and in order to be able to kind of hold his belief or save it from falsification, will engage in all forms of irrational dissonance reduction. I've got a nice little clip for you. I want you to go watch. Just click on the link in the slides you'll also find on Canvas. And there's our good old friend, who else could it be? Donald Trump, who's actually denying that climate change is caused by man, and who's interviewed by a journalist from the BBC. And there she points out the overwhelming scientific evidence for the fact that human activities create climate change. So he's denying that, and he says, well, you should show me the scientists. And then he actually, and she says, well, they're overwhelming. And what he comes up with is, well, you must know scientists also have a kind of political agenda. And so he kind of reduces the dissonance by saying, well, it's not because, the evidence is overwhelming. It's just because these scientists are left-wing people who, for some reason or another, want to exaggerate human-made climate change. Anyways, go watch the clip and you'll find a very good example of cognitive dissonance reduction, and you'll see why this can be such a problem in the world. All right, and then finally on to the last source of reasoning errors, the reasoning errors stemming from system 2. So the bias, the mother of all biases, that affects us when we start using system 2, when we start consciously reasoning, looking up new information and so forth, is of course the confirmation bias. You're all very familiar with the confirmation bias by now, and we've seen that the scientific context, well, kind of protects against this confirmation bias, or does it very well. Why? Because there's this culture of open criticism, and so while scientists themselves might be in the throes of their own confirmation bias, well, the counter evidence and the counter arguments, they come from other scientists. But we can also kind of protect our own thinking against the confirmation bias. And if there's anything we should learn to do as critical thinkers, it is this: protect ourselves against this important confirmation bias. And the first way to do so is to play devil's advocate in our own thinking. So spontaneously, as mentioned many times before, well, we're not inclined to do so. What we're inclined to do is to look for confirming information, to imagine confirming arguments and so forth, and we're just blind, we don't know it, but we're blind to counter arguments and counter evidence. So by knowing this and actively making an effort to look for not confirming evidence, that will do anyways, but also look for disconfirming evidence, for counter evidence, for counter arguments, well, we can set our thinking straight. So that's a very important exercise we can and we have to engage in order to reduce the distorting effects of our confirmation bias. So next time you have a certain kind of opinion, you form an opinion about something, great, but first also try to make an active intention to go look up everything that could possibly refute your argument, or at least everything that could possibly go slightly or not against, the conclusion you are drawing. And then the second way, we can do this for ourselves, but we can also have other people do that for us. And so we can surround ourselves with people who think differently, who will have a different opinion, and therefore will have looked up different kind of information, different kind of arguments. And so by listening to these people who give us our counter arguments or counter information, well, we can set our thinking straight as well. Now, much as we're not naturally inclined to play devil's advocate in our own thinking, we're also not naturally inclined to surround ourselves with people who think differently. In fact, and social psychology shows this, people are very likely to befriend people who think pretty similarly to themselves. And it's just much nicer being together with people who agree with you than people who constantly, go against your opinions and reason with you. So we're not really prone to do that either, but it is an important part of improving our own thinking about certain matters. In fact, we see that companies that have board of directors in which there's much disagreement and people actually listen to the counter arguments of others. So the CEO actually listens to what other directors say when they go against the opinion of the CEO. Well, are companies that in general do much better than companies in which, and you can easily see this from the nodules from these boards of directors, They do much better than companies where there's not much disagreement, when there's lots of hierarchy, so everybody just says yes because the big boss says so. They do in general much better. So very important, people who think differently can set our thinking straight. And that brings me to an interesting finding, and that is that groups generally predict much better and have much better estimates than individuals. And that phenomenon is known as the wisdom of the crowds. The wisdom of the crowds was discovered by Francis Galton, and you see him on the picture here, a statistician, actually a cousin of Darwin's, a statistician of the 19th century and a scientist, and he did lots of stuff. He was also a statistician, and he went to this kind of fair, and in this fair there was this kind of raffle, if you will, and so people could participate to a competition, a guessing competition, if they paid a small amount of money. And the guessing competition was to guess the weight of a big ox that was being shown there to the people. Galton was very interested in how these estimates would go. And so there was a large group, 100 plus people, estimating or guessing the weight of this ox. And so these guesses went all over the place. Some radically underestimated the weight, some radically overestimated the weight. And what Galton did is he took all of these estimates, he took them, he wrote them down, and he discovered, and this has been replicated many times, he discovered that the median answer, so the answer of the person who had as many people guessing a larger weight as people guessing a smaller weight, that this was incredibly accurate. It was less than 1% of the real weight of the ox. And as I said, this has been replicated many times. So the median answers of a large group of people estimates very accurately, because there's no reason why people would in general rather overestimate than underestimate this. So the median answer, when it's a large group, actually comes very close. But very importantly as well, for this wisdom of the crowd to emerge, is that the participants, well, they form their opinion, they give their estimates independently of each other. If they're going to start talking about each other and influencing each other's estimates, then the wisdom of the crowds disappears, because then you got all kinds of conformism and in-group biases distorting this whole. So the most influential people will influence more people, and their wrong estimate will be taken over by too many people. But so when this is done completely independently, well, this is incredibly accurate. And there's another link there of the replication of this very experiment on Dutch television. So for the Dutch speaking among you, it's pretty entertaining. For the non-Dutch speaking, well, even you can watch it, it's pretty obvious what is going on. So they have a whole bunch of they have a small calf they put there in the street, and then they have people just passing by in a shopping street, like guessing the weight. This goes all over the place. And then they have an expert who's, he's a farmer, he's an expert, he knows everything about the weight of these oxes. He feels the ox, he can do everything except put the ox obviously on a scale. And he gives his estimate as well. Well, turns out the median answer of the crowd was much more accurate than the guess of the expert. And this, as I said, has been replicated many times for many problems, be it predicting economic outcomes, political outcomes, and so forth. A large sample of people giving their kind of predictions, well, they do better in total when you take the median of their answers than even the best experts. So the wisdom of the crowd. All right, so to deal with our confirmation bias, which leads to this overconfidence bias, we have to play devil's advocate in our own thinking, but most of all, we have to include the thinking of others. Groups are smarter than individuals, and by exposing our thinking, our beliefs, and our arguments to the critical eye of others, we increase the accuracy of our own thinking. And that kind of also rids us of this strong overconfidence bias we have, the fact that we overestimate the accuracy of our knowledge and of our predictions. And that overconfidence bias, well, that is pretty strong. On average, when people estimate the chance of being wrong about something as small as 1 chance in 100, they're only right in 73% of cases. When they estimate the chance of being wrong between 1 in 1,000 and 1 in 1,000,000, so incredibly negligibly small, you could say, even then they're only right in 85% of cases. So we standardly come with unwarranted confidence in our beliefs, a strong overconfidence in the rightness, the accuracy of our beliefs and predictions. And interestingly, the people who tend to feel very certain of their opinions, of their information, of their knowledge, of their predictions, the people who are always 100% certain that they're right, well, they do the worst. They have the strongest overconfidence bias, obviously, but they also make more mistakes. So the people you should have bets with are the people who are always 100% sure, who do not have a single shred of doubt in their mind. They are the worst in predicting. People who think something but remain somewhat humble and doubtful about whether or not they are right, well, these are the people in general that predict much better. And that makes a lot of sense when you look at it from the perspective of the confirmation bias, because the more certain you feel about something, the bigger, that tunnel vision, the stronger that tunnel vision will become, and the more it is likely that you will miss, counter evidence and information that goes against your belief or your conclusion. So, in order to improve our thinking and in order to get or to rid ourselves of this strong overconfidence bias, well, we must step out of our cocoon. We must expose, as I said, our arguments and our reasoning and the information we think is accurate. We must expose that to the critical eye of others who may have different opinions, who may have seen different information, who may have come up with different kind of arguments. We must step out of the boundaries of our isolated thinking in order to improve our thinking, in order to get rid of our confirmation bias and of the overconfidence bias that follows from it. And this brings me to a more general observation, and that is the important question: what makes humans so smart? Now, we call ourselves the intelligent species, Homo sapiens, and indeed, when we compare, human culture and human technological innovations and science and art and whatnot with the cultures of other species, even the most intelligent other species like the chimps and the bonobos, well, there is obviously a massive difference. Chimps still live their natural lifestyle, and they haven't really changed anything there, and humans have completely altered the face of our planet and come up with innovations that radically alter the way we live, but also with theories, scientific theories and so forth, that understand the world on a much more accurate and much deeper level than any species could ever do. So what makes us so smart? Well, for a long time, and many people assume this, it is our large brains. And we do indeed have pretty large brains, but these brains in isolation, these biological brains, well, for the most part of our history as biologically modern human beings, they didn't bring us much further than tending fire and making some rudimentary tools. So we've been biologically modern for 200,000 years. That's how old Homo sapiens is, more or less. But for 190,000 years, that didn't bring us much further, as I said, than tending fire and making some tools and running after herds, being eaten by some predators and killing some kind of prey. So nothing too spectacular there. So what enabled the last 10,000 years this incredible cultural jump, if you will. That is the question, the important question: what makes humans actually so smart? And a very interesting, and I think right on the mark, hypothesis is that what makes us smart is not these biological brains, but actually the external elements we use in our thinking. And that is the so-called extended mind hypothesis. Human cognitive mental processes use elements from the environment to scaffold their thinking, to put their thinking on a higher level. So what are these external elements? Well, there are three important cognitive levers, if you will, three important scaffolds that increase the power of the human mind. And the first of all are other minds. We're an incredibly cooperative species, and unlike any other species, we're able to pool our knowledge and to work together in creating that knowledge. Think about scientists who work in teams, but most importantly, we collaborate on creating knowledge not only at the same time in, for instance, groups of scientists or groups of people developing certain kind of things, but throughout time. So this kind of diachronical cooperation, we build our theories now on the findings and the breakthroughs of the past. Without Newton and the developments in mathematics, well, Einstein could never have come up with his theory, and the next generation of scientists is building on the breakthroughs of Einstein and so forth. And so because we're able to build on all of these achievements of other people, of other minds, well, we can massively increase, the power of human thinking. We can become incredibly more smart as a species. In fact, according to evolutionary and cognitive psychologists, what sets human thinking apart from thinking of our closest evolutionary cousins, the chimps and the bonobos, are actually very few things, but among those, there's obviously language as well, which enables us to communicate, but even more importantly, and language plays a role there as well, is the fact that we can work together, collaborate on creating knowledge, that we can pool our knowledge, build on the knowledge of others. So this is the absolute game changer that explains this enormous difference between human knowledge and the knowledge gathered by other species. A second very important factor is the fact that we've developed cognitive artifacts. What are cognitive artifacts? Well, there's two important cognitive artifacts. First of all, mathematics. Developing math has enabled us to interpret our environments in a radically different way. In fact, without mathematics, you couldn't have most modern sciences as you have today. So it gives us a completely different and actually very powerful way to interpret, to first of all, classify and then interpret information from our environment and to make all sorts of predictions. But also language is an important cognitive artifact. It's very important to collaborate on knowledge, the point we just mentioned, but it's also very important because it allows us to question our representations of the world. So by having these representations verbalized, put in a linguistic form, we can actually start questioning the accuracy of those representations. We become aware of having these representations in the first place, so that enables us to question our worldview and to come up with new and better theories of the world, to form what they call in the literature meta-representations, representations of representations. And then finally, a third very important cognitive lever are instruments. Now, these instruments range from the development of writing, which obviously enables us to store much more information much easier and to not have the distorting effect of a fallible human memory. But also it really supports our reasoning processes. Think about writing down mathematical equations that help us solve these equations. So it supports our reasoning in a very real sense. But then also, obviously, we've come up with a whole variety of instruments, especially in our recent history, that enhance our thinking massively. Think about the tools modern scientists use today that radically extend the scope of their senses, of their perception. Think about telescopes, for instance, enabling us to peer into far-off galaxies that otherwise we'd never have any kind of data from, never any kind of information from. But also think about calculators or computers radically enhancing the computational strength with which we will interpret these data and which we can make predictions and all sorts of things. So what makes humans so smart? What enables modern science and these mesmerizing innovations that follow from it? Well, these not the biological brain in isolation, but the fact that we can pool knowledge and work together with others in creating knowledge. The fact that we've developed very efficient and powerful cognitive artifacts such as mathematics and human language. And finally, the fact that we're most recently now developing many instruments that increase the power of our own thinking. And so, in conclusion, you could say that in order to improve our thinking, we should outsource our thinking. We should realize how limited our thinking is when it happens in isolation. And a good example of that is the success of statistical prediction rules. Now, statistical prediction rules, these are formula in which different relevant factors are being given a certain statistical weight in order to predict something. And these formulas, they are being shaped by the analysis of big data sets. And it turns out that such statistical prediction rules, well, they enable us to predict very accurately an incredibly broad range of different phenomena, like, for instance, the quality of the wine you'll have based on the climatological data you get from harvesting the grapes and so forth, the chance that a marriage will work, the chance that a criminal will commit a crime again when he's released, the chance that somebody a bank lends money to will actually be able to repay his loan, in the area of medical diagnosis, and even to predict the productivity of a job applicant. It seems that in all of these domains, and there's many more, statistical prediction rules do at least as well as the best experts and often outperform the best experts. So a typical case in which human thinking is actually scaffolded and becomes much better by actually, you could say, outsourcing that thinking. And that brings me to the final slide before the summary of today, and that is that critical thinking, in a way, is thinking about thinking. First of all, it's having a certain kind of humility about your own thinking, knowing that human thinking, and so also your own thinking, is pretty limited and pretty biased when it happens in isolation. So whenever we come to a certain conclusion of a belief, we must ask ourselves, how did we form that belief? Does it arise from intuitions? And if so, in what kind of context is it applied? We must ask ourselves, have we used all of these external levers, these scaffolds, to increase the power of our thinking? Have we used other brains, other people with different kind of ideas in order to enhance our own thinking, to check our own thinking, to check our thinking for reasoning errors? Because as we know, it's much more easy to detect reasoning errors in others than in our own thinking, the so-called bias blind spot. So have we made sure that we are not blind to our own reasoning errors? It is therefore thinking about thinking and knowing the limitations of our own thinking, and that goes for every human alive when that thinking happens in isolation. As Einstein, one of the greatest thinkers of the 20th century, said, "It is not that I am so much smarter than others, but I stay with the questions much longer." Now that is critical thinking. All right, so to wrap it up, let's have our summary. And again, I would advise that you kind of stop the recording briefly and try to answer these questions for yourself. So how do we protect against reasoning errors coming from, first of all, intuitions? Well, we must check their origin. What is the origin of their intuitions? Is it an innate intuition? Then we must check in which context we apply it to. It is only reliable if we apply it to an ecologically valid context and if there are no other pitfalls associated with intuitive reasoning, like seeing patterns that aren't there and so forth. And then secondly, a second possibility, is that these intuitions are acquired. If they're the process of a reliable learning process, we can assume that they are reliable as well. Then how do we protect against reasoning errors coming from our emotions? Well, first of all, we must be aware of the fact that emotions distort our thinking. They can determine which emotions we take on board, in-group, out-group bias. But even more importantly, it seems that because we develop these emotional ties with certain kind of beliefs, that we engage in irrational cognitive dissonance reduction whenever we have counter beliefs. So a critical thinker in that sense is also to a certain extent a dispassionate thinker. He's aware or she's aware of the fact that when we're too emotionally involved, we're not as objective as we should be. And then finally, how can we protect against the reasoning errors of system 2, the confirmation bias and the overconfidence bias that follows from it? Well, first of all, we must be aware of these biases. Again, if I can convince you of one thing, that is to keep your confirmation bias in check, the most important bias. And we can do so by, first of all, playing devil's advocate in our own thinking. When we come to a conclusion, well, we should develop the habit of asking ourselves what kind of information or what kind of arguments would actually refute or at least, put some question marks after or behind our conclusion. And we should go look at the possibilities of that information. And then finally, as I said, also, we must surround ourselves with people who think differently. We're very good at seeing the faults in the reasoning of other people who argue for things we do not agree with, but we're very bad in general at seeing the faults in our own reasoning that we leave up to, or that we, in a way, have to leave up to others, given our biased blind spot. So surround yourselves with people who think differently once in a while. Test your own arguments, test your own information, and listen to these people. You don't have to agree all the way, but they will improve your own arguments. They will improve your own thinking about certain issues. All right, that's a wrap. That's it for today. Looking forward to talk to you next time, and that will be about the importance of rationality. Why should we bother with critical thinking in the first place? Thank you.